Hi, Amy. Playing a song I knew that would give a smile to your face. Good morning, everybody. Had some intro music by Widespread Panic. That was a September 20th, 2016 live show from Pensacola, Florida, in case anyone was curious. If you have not yet checked out Widespread Panic, I highly recommend you do so. And I know that for at least one of our guest speakers, Amy Verbaten, it's one of her favorite bands. And Nick was smiling quite a bit, so maybe that made him happy as well. All right, welcome everyone. I did type in a few questions into the chat. Importantly, I would really like you all to be thinking about a couple things. First of all, on your screens, raise your hands if you're planning to see your family over Thanksgiving. Okay, lots of hands going up. Okay, Addie, Taylor, Caitlin, Katrina, Corbin. All right, all sorts of folks are planning to see their families. Keep your hand up if you have a plan for keeping your family safe from getting the coronavirus. Okay. Seeing lots of hands up too. Good. I'm going to go get a giant Q-tip shoved deep inside my nose today at the testing center, and it's free. You can have a giant Q-tip shoved up your nose for free at the Boise State Testing Center too, and I would recommend you do that. Keep in mind that only tests to see if you actively have the coronavirus right now. So other measures I'll be taking over Thanksgiving to keep my elderly parents safe is I'm just going to keep wearing, or my whole family, we're going to wear our masks while we're around them, even inside, and keep our doors shut in the place where we're sleeping and the window open. So checking with my doctor friends, that is something that they recommend. So all of you, please keep yourselves and your loved ones safe. All right. We're going to get going here. Just a few announcements. Some of you did not see the assignment for the soils and climate change. You have until Wednesday at midnight to finish that. That's under week 13. I see Zakiah looking quite perplexed. So yes, I think quite a few of you are quite perplexed, and that's okay. You have a couple extra days. It's a really quick assignment, should take you about 10 minutes. So do check under week 13 under the readings and complete that. Other quick assignments. You have extra opportunities for extra credit. We really want all of you to do well in this class. So please check the announcements for extra credit opportunities. What else? No class next week, right? It's Thanksgiving, so we will not be seeing you next Tuesday, but we are very much looking forward to all your excellent poster presentations. So make sure that you turn in your digital poster drafts on time and are ready to give your presentation. That's a huge chunk of your grade. Okie dokie. At this point, we are going to have a presentation by Nick Kollerick. Is that how you say your last name, Nick?
Yeah, that's good.
It's good. It sounds like it. How do you say your last name?
I say Kollerick, but I'm not offended by any pronunciation.
Well, if you say Kollerick, then I'll say Kollerick. Nick Kollerick is a PhD student working with Jody Brandt in the Human Environmental Studies and Systems, program here at Boise State. Nick is interested in using remote sensing and geospatial technologies to measure human impacts on the environment. He got his MS in applied geography. Woohoo! I have a master's degree in geography. It's the best. Geographers know where it's at, but geologists know what makes the bedrock. Oh wait, shh, I didn't see that. Seeing if you're all paying attention. Nick has a bachelor's in geography, also with a concentration in environmental analysis. These are both from the University of Louisville over in Kentucky. So Nick, I gave you co-host status, so go ahead and take it away. We'll have a pop-up presentation by Nick and then turn to our guest speaker. All right. And we'll see if we can, see if you can share your screen if you do have slides to present. While Nick is getting that up, I do have a Jamboard thing I'm going to try with you guys. I'm going to try to paste that link into the chat here for later. We'll see if that works. Ooh, it's a long link. All right, Nick, are you able to share your screen yet? Oh, there we go.
Yeah, thanks so much for the warm introduction. I'm really happy to be here today. I got really excited about research as an undergraduate, so I always like these opportunities, and I hope that I can have the same effect on you all. Yeah, so as was mentioned, I'm part of this Human Environment Systems group, and what's really unique about this group and what was really attractive about Boise State for me was this commitment to viewing these problems as social ecological problems, right? Not that these human and ecological systems are not acting alone, but rather the interactions, that it's this one system that we need to approach to find holistic solutions to these very thorny and wicked problems. And one of those is water resources throughout the landscape, and particularly the American West. And we focus in the high divide. And so something that is unique about the high divide is, if we're not familiar, it's this area between these relatively intact ecosystems, the crown of the continent and the greater Yellowstone, so eastern Idaho and western Montana. And this land functions as kind of a conduit between these relatively intact ecosystems, providing refugia for a lot of different animals and wildlife on the landscape. But it's also very productive and seeing a lot of human development. So when we develop on the landscape, typically we develop in these valley bottoms. And I once heard a manager say or equate these valley bottoms to sponges, because their function is to absorb water, release it in periods of excess, and store it in periods of deficit. But as we develop, the problem is that we're changing the way these sponges function, because we don't allow these wall-to-wall wetland complexes as would typically play out, but we have to channelize this water to make room for our infrastructure, right? And so what this does is it increases the speed at which the water leaves the system. Further, we've extirpated a keystone species from our landscape, the beaver, right? And when they develop in valley bottoms, they do exactly the opposite of what humans do, right? They increase channel complexity, they slow the rate at which water leaves the system, and they allow for these wetlands to develop. And so the combination of our changing climate and the increased amount of development and the extirpation of beaver has led to these really deep cut incised channels, because when we straighten these channels, it increases the erosive power, and it cuts or incises into the riverbed, and it disconnects these streams from their historical floodplains, and they require intervention. So these dry conditions and these incised channels lead to really highly altered systems that require attention. So we have all these questions. We need to figure out where these sponges are, quantify these wetlands extents and how much they're changing. And then we're interested, with this social ecological systems approach, what is the human role in this? How does management change that? And when we try to kind of, as I mentioned, reconnect these streams with their historical floodplains, does that work? And so we want to use remote sensing data for this. And a quick primer on remote sensing. Passive remote sensing is simply just measuring the reflected amount of solar energy off of different portions of the landscape. And just as you and I look out there and we see green vegetation, we see dark asphalt, every land cover has a unique signature and reflects different portions of the sun's energy differently. So you and I, we may take a photo, and we're seeing energy reflected in the visible portion of the electromagnetic spectrum. But we found that beyond that, in this near infrared portion, we get really valuable information as well. So on these satellites from which we are collecting these data, we have these channels of data, say in the visible portion. So we have a blue channel, green channel, red channel. We're also collecting into this near infrared and mid infrared. And the near infrared is really what I want to focus on here or hone in on, because we can see with these spectral curves, these spectral signatures of different land covers, that water is almost a perfect absorber of near-infrared energy. And green vegetation, that active chlorophyll, is a very good reflector of near-infrared energy. So what we do is we use these simple ratio-based indices. I know this looks a little mathy, but really all this is saying is that the reflection in the near-infrared portion minus the reflection in the red portion plus or divided by their sum, and we can use this index, this normalized difference vegetation index, to measure different types of vegetation based on their phenologies, right? How when they green up and when they senesce. And so we can kind of draw distinctions between different types of vegetation. And in our context, that's really important for seeing where water is, right? Because mesic areas, that's wetland areas and areas with access to water, will be greener longer than will upland areas. So active remote sensing is a little different. This example is for radar, radio detection and ranging, and I'm sure we're all familiar. You know, we're all always looking out for cops on the side of the road that have a radar gun, and what they're doing is emitting a signal, and they will then measure the length of time that it takes to get that back. So we're doing something a little different from the satellites, where it's emitting a signal at an angle. And where we're not receiving any backscatter, we consider that to be a smooth surface, right? So like open water maybe. And then if the surface is a little rougher, like maybe this forested area here, the backscatter will receive some of that back, but maybe not all of it because it's kind of scattered kind of throughout. But then when we find some inundated vegetation, perhaps, we get this double bounce signal and we receive a lot of that backscatter back. And so we can physically measure the differences across the landscape rather than just optically. All right, so why is this useful, right? So remote sensing has been used for quantifying water resources before, but the problem is that folks typically use data delivered at kind of a coarse resolution, one of those being the Landsat time series, which is delivered at a 30-meter resolution. This has problems for us in the West because a lot of these water resources are much smaller than that. But we're going to try to use a newer data set from the Sentinel time series that delivers data at 10 meters. And this way we can get a more complete picture of how much surface water and mesic resources are on the landscape. And to exemplify this, this is just below the Island Park Reservoir in Fremont County in eastern Idaho. And so this is the confluence of Buffalo Creek and Henry's Fork right here. And we can see that in open areas of water, we're able to measure open water very effectively. And this is like the leading science group with this really complex algorithm, but it still struggles just based upon the input data, right? And because it's a coarser resolution. But when we use a relatively simple extraction index with these Sentinel data, we get a much more complete picture of how much water is in the landscape and a better understanding of how things are going. And we use the radar data in tandem with these optical data. So we can see here on the left in all these panels is Silver Lake. It's a shallow lake. And so there's the submerged vegetation that confuses these optical sensors, right? Because it sees that vegetation underneath. But since we're depending on this smooth surface from the radar backscatter, we can differentiate between our land and water a little bit better. So we're getting these complementary sources of information, and we're really excited about it. I know this plot is kind of wild, but I really like it because what it shows is where maybe the optical sensor, and we're looking at vegetation covers, confuses vegetation with similar phenologies like willows and grasses that are found in mesic areas. With the radar data, we're able to separate these based on their physical properties, and that's really exciting for us because managers often talk about, you know, we want to see wall-to-wall willows in our valley bottoms, right? So we want to use all these cool data to do useful things like measure differences in how well we're managing our landscapes across public lands. And we know that a lot of water resources fall on private lands because we're developing in these valley bottoms. So do conservation easements work? And these are tools used to restrict development on private lands. And all this is made possible by working with what we like to call in social ecological systems science our knowledge brokers. So this is Amy at Friends of the Teton River and her colleagues at Henry's Fork. They really help to contextualize what we're seeing from these satellite data, because one of the dangers with working with these satellite data is having a view from nowhere, right? If we have no context, then we really can't tell you what we're measuring. So lastly, something that's really exciting is this partnership with Beaver as we try to restore the valley bottoms, right? And it's become under a lot of scrutiny recently because of the prior appropriation doctrine and the delivery of water rights downstream. So in short, folks are concerned that they're not going to get their water downstream if they have a paper water right. Because what we do with these low-tech process-based stream restoration techniques like beaver dam analogs is we put these low-tech, low-cost woody structures in the stream. We increase channel complexity, and hopefully we can create conditions that beaver will want to come and move back in. And then they kind of maintain this process, right? And what it does, it slows the way water moves through the system. And see in this figure here, it kind of raises the water table because that water can then kind of infiltrate down to the aquifer, right? And that's all things that we can measure, or we hope to be able to measure with these remote sensing data. And all of this kind of has huge implications for how that high divide is functioning as that conduit, you know, that passage between these ecosystems that hold a lot of iconic wildlife in our region. So thanks so much for having me, and I'm happy to answer any questions.
Great job. Thank you so much, Nick. I actually just jumped up to try to get this copy of my flyer for the Beaver Believers off my door, which is a great documentary that I saw last spring. I would definitely put it on your watching list for Thanksgiving, the Beaver Believers. Some questions and notes I took down from Nick's talk were, for example, how might beaver act as sponges on the landscape? And how does Nick use his near infrared signal? So these might be questions you might see again on, for example, a quiz. So this would be a good time to ask a few questions. If you don't know the answer to those questions, here's your chance to ask Nick. So let's either see some questions in the chat or go ahead and raise your hands. I'm looking in the participant bar to see if there's any hands up. Don't be shy. Anyone? Bueller? Okay, let's see. Jody said, great job, Nick. I would agree. Nick, I have a question for you. So I really appreciate your reanalysis of the remote sensing data. And this is, of course, a 100 level class, so that, really trying to understand how satellites can or can't help us understand water resources. What would you say for your upcoming PhD work, your greatest challenge might be in terms of using the remote sensing data, or just what are you most looking forward to? So biggest challenge, thing that you're most looking forward to with your data.
I think that they're one and the same, and the biggest challenge for me is how much data there are. But that's also really exciting because we have so much data, and these days we have the tools that we can process them. With cloud computing and Google Earth Engine is the platform that I use, which is freely available, and we're using all freely available data. So I think it's, I'm really excited about the prospect of using, data that are ours, data that our tax dollars pay for, to do useful science, and that it's replicable. That we can write some code, a couple of lines of code for an analysis, and share that with folks that are interested in using that themselves. And people can, there's a lot of information about how to access these data and utilize them. So it's a really exciting time to be working with satellite data. There are a lot of them. We just need to figure out how to use them and be smart.
I really like that. And a good reminder of how science, of course, is helping us in our everyday lives. There's a lot of distrust of science, both for COVID and climate change. And this is a good reminder about how the fact that we're talking to each other via Zoom, and Nick's data depends on satellites. Some great questions in the chat. Thank you. First from Maddie. To clarify, you use the radio signals to find water in an area. So can you help clarify that?
The radio waves, the radar? Yeah. So what it is we are emitting, or rather, aboard the satellite, it's emitting a signal as it's orbiting, right? And so then it's also collecting that backscatter information. And so different land covers will have different backscatter intensities. And water, it's that perfectly specular surface, perfectly flat, with flat water anyway, right? So, and so we expect to see really low backscatter intensities in those areas. So if you were to see, like the image I showed was a river, and it was inundated, so it was flooded. So we can see the river in that image because there's a low amounts of backscatter being returned there. Whereas, where the forest is adjacent to the river, we see that backscatter intensity changing because of the way that signal is interacting with the landscape.
Awesome. That was a great explanation. Thank you so much. Another question from Celia. What introduced you to this topic of study, or why are you interested in pursuing a further degree in this area?
Yeah, so for me, it's not all right. So for me, what it is, it's about building tools and a skill set. It's not necessarily the problem. I'm really just trying to kind of accrue a lot of different skills and tools. And I got really excited as an undergraduate about GIS, and then I learned about remote sensing imagery and about all these data that are available. And just like the potential power of all these data and what we can, like all the questions we can ask and all the analyses that we can do, it's unlimited. And I got really excited about that. I did my master's in looking at vegetation structure, so a totally different kind of problem, but similar methods and techniques. And I'm just kind of really excited about expanding my skill set, and I guess answering the latter half of that question, what inspired me to do an advanced degree. It's like I want to be able to answer the questions that I'm interested in, rather than someone telling me what I need to do. Right? So I can follow the threads that I want to follow, hopefully, rather than someone, I guess, assigning me something that I don't want to do.
And I hear you. And that's if you don't like to be told what to do and when to work, I recommend academia. You'll work harder and get paid less than most other people, but you'll get to do what you want to do, kind of, except grading. I'd like to bring Amy Verbaten onto the scene here. Amy is, so stay with us, Nick. Amy is our keynote speaker. Amy holds a Bachelor of Science in Biology. Let me put this up for you. With a minor in geology from the University of Washington, a Master of Arts in Education from Prescott College, and a Colorado State teaching license. Amy is the executive director of the Friends of the Teton River right now, and I am fortunate enough to be on the board of the Friends of the Teton River. So I get to work with Amy and her staff and learn about all the wonderful things they are doing. I'm going to shorten this a little bit. She's has a lot of experience with outdoor education in her past, and currently lives in the beautiful Teton Valley of between Victor and Driggs in eastern Idaho. Nick referred to Amy as a knowledge broker, which I think is a great term. I'm going to bring Amy on here so she can say hi to Nick. Amy, are you out there?
I'm out here. Yeah, thank you so much. Thank
Yeah.
you, Nick. It's really exciting to get to work with a student like you who's doing this really neat cutting edge work, and then to see it presented like this. So we are really excited for the work that you're doing and the opportunity to partner with folks who bring skills and knowledge that we as a small nonprofit organization, we don't have that capacity. And so I'll talk a little bit more about that in my presentation as well, but it's really neat to see you presenting this work that we've been hopefully bringing some knowledge to. So that's great.
And I thought that was really neat too. I have Nick and Amy on either side of my little Brady Bunch view here. And to see how the good science that Nick is doing is helping inform management decisions that Friends of the Teton River is helping to understand. So I think that's a really great connection between science and community. So thanks again, Nick. And I know Nick's advisor, Dr. Jody Brandt, is on this as well. So please feel free to, Nick, if you can enter your email into the chat, that would be great for students as well. And please continue to ask Nick questions as we go along. We're going to move into the next segment of our class, which is our keynote speaker, Amy. And we are very excited to hear about common ground and agricultural solutions to climate change. So take it away, Amy.
Thank you so much. I am going to go ahead and share my screen.
Great. And we see, yep, there we go. It's in presentation mode. Perfect.
Fantastic. All right. So I am just absolutely thrilled to be invited to do this. As somebody who cares a lot about my own climate footprint, my carbon footprint, I'm also excited to be able to do this without having to travel, although I would love to meet all of you in person to be able to do this. From Driggs, Idaho, where I'm currently sitting, is also a really great opportunity. I am gonna get us started here by actually asking you all to do a little bit of reflecting. I'm going to ask you to participate in a poll. It should now be active. And I'm going to ask you, on a scale of 0 to 10, when you look at the photos here on the screen, how well did these photos fit your previous mental image? So before this class, this semester started, I know you've probably had some changes in your mental images. How well did these photos fit your pre-semester mental image of leaders in the field of climate change solutions? So I'll give you about another 20 seconds to participate in the poll. And I'll give you about 10 more seconds. See a couple more votes coming in. And I'm going to go ahead and end the polling. So you all are a lot more progressive probably than I was before I started this work. So I think when I started this work, these were not the folks that I thought of as leaders in the field of climate solutions, of developing climate solutions. But I hope that at the end of this, you will share some of my same thoughts that I have now about what role agricultural producers can have in the field of climate solutions. So I'm going to advance my slide, but for some reason I'm a little slow in doing that, so I apologize. Let me just take a second. There we go. So as Dr. Pierce mentioned, I work for Friends of the Teton River. We are a nonprofit organization, and our mission is that we work together with our community for clean water, healthy streams, and a thriving wild fishery in the Teton River watershed. That's not specifically climate focused, as you can see, but climate plays a huge role in the work that we do. Today, I'm going to present a case study for how we are working together with our community to address climate change and to develop climate solutions in our region, in the Teton Valley of Idaho and Wyoming. And at the end, we'll be prepared to discuss the questions that are here on this slide. So I'll give you just a second. I'm not going to read them for you, but I'll give you just a second to read through these questions and to kind of supercharge your mind around these questions that we'll be discussing at the end of class. All right, so hopefully you know generally where we are going. I see most eyes kind of stopping their active movement, so I think that means that folks have had a chance to read through these, and you will see these questions again. So just a little bit of context. Nick's maps were, I think, nicer looking than mine, but just the context here, we're working right up in the very eastern part of southeastern Idaho, right up against the border with Wyoming and fairly near the Montana border. We work in the Teton River watershed. We're, as I said, right on the Idaho-Wyoming border, and to our east, we look out at the Teton Mountain Range and Grand Teton National Park with Yellowstone very close as well. Nick gave some great slides and examples of this as well, but our economy here, our way of life is based on a combination of agriculture and recreation. And that recreation is also driving a lot of change in our community. We are seeing previous agricultural land being rapidly developed as folks more and more want to come here for the beautiful place and the beautiful outdoor and recreational amenities that we have. We, as all Western watersheds that I know of, are experiencing climate impacts here locally. This is not a graph of the Teton River where I work, but it's very close by on the Snake River. It's been studied a little more extensively than the Teton. And we are experiencing climate impacts, as I said, just like all other Western watersheds. We are having earlier runoff. The snow melt that we depend on for all of our water, our drinking water, our agricultural water, is coming off faster. It's running off faster as a result of warming temperatures. And then because it's coming off faster, we are then seeing lower flows in the summertime. That is then resulting in warmer stream temperatures. This is modeled stream temperature into the future, but we are experiencing measured increases in stream temperature during the middle of the summer as well. So those changes affect our entire community. They affect our well water that people rely on for their drinking water in the rural county. They affect the wells that our cities rely on for their drinking water. They affect the level of the Teton River itself and the temperature in the river, which impacts fish and wildlife that I care about a lot. And then they have economic impacts on our agricultural producers, as those folks are less and less able to get the water that they rely on for irrigation. These changes are impacting our entire community, and we are all seeing that on a day-to-day basis. And as a result, those changes that we are seeing are driving community solutions to these problems. And to me, that is a lot of what we hear about climate change is scary and bad. But to me, the changes that we are seeing that are driving solution generation in our local community are incredibly hopeful. And that hopefulness, these solutions that are being driven by people who may not look like we in the, you look at this picture. In the rural West, the media that we're seeing, this is not people working together who look like this. That's not what we're seeing out there, but that's what I'm seeing day to day in my work. And it gives me a tremendous amount of hope for the future. And so really what I want to share today is this extremely exciting and extremely hopeful work that has tremendous potential for change. So what the kind of foundational theory behind what we are doing has been named collaborative conservation. I'll let you take just a minute to read one definition of what collaborative conservation is. And I think that a lot of this comes to a lot of what Nick just said about working together to bring local knowledge. So the knowledge brought by agricultural producers who've been working on this land for generations with the science brought by folks like my organization, people at Boise State and other institutions. Colorado State University has a great center for collaborative conservation. University of Montana has some really neat programs going on in collaborative conservation. Bringing this all together to a community that's willing to participate in active solution generation. And this is what it looks like on the ground. These two photos, I think, are really great examples of how this looks here in my community. We spend a lot of time sitting together. This is pre-COVID, so none of us are wearing masks. This is back in 2016. So we spend a lot of time sitting together in community meetings with lots of diverse voices and ideas and solution generators. And then we spend a lot of time out in the field. This is a field of quinoa. I don't know if any of you have ever seen quinoa growing, but it's one of the neat new crops. And this is a fourth generation landowner working together with our science staff out on the ground. So the things that we're doing, what I'll focus on today is what's in yellow. We are actually working together here in our community to address some of the root causes of climate change by implementing a regenerative agriculture initiative. Some of the main goals of this are reducing carbon emissions, increasing carbon storage in the soil, and then also reducing some of that conversion or the potential for future conversion of agricultural land to developed land. And we'll talk a little bit about why that's important. We're also doing some additional work to adapt to climate change through an aquifer recharge project. I'm not going to talk about that today, so that's down in white, but I would encourage you to visit tetonwater.org for more info, and there is an active link in this presentation that'll bring you straight to some of those resources. Some of the aquifer recharge work is really similar to the work that Nick is doing, and it's actually there's some really neat things that we're learning about how that aquifer recharge is reactivating wet meadows and wetlands, which is actually also addressing the root causes of climate change. So really integrated work there as well. But I'll focus on what's in yellow here today. So essentially what we're doing, some of you, I know that you all last week had an opportunity to delve into the way that soil can really be a solutions. Soil itself can become a climate change solution. And so what we're really doing is trying to activate those principles. Carbon farming, where agricultural production itself and agricultural lands become net absorbers of CO2 rather than net emitters of carbon dioxide. And so there's really two things that we're doing is we're working on the left-hand side of this column to increase soil carbon. And then we're also simultaneously working on the right hand to reduce the depletion of soil carbon. And so I'm going to talk about a number of these practices that we are implementing here on the ground. I'm not going to go deeply into the science behind it because it sounds like you all have already had a great primer in that. But as we go through, think about those principles that you learned about last week, soil as a carbon solution. So the Teton County Soil Health Initiative is being led by the folks in this picture. You may remember seeing them before at the beginning of this presentation. The goals or the practices that we are doing. We purchased a no-till drill. We're experimenting with a number of agricultural best management practices. We're gathering data on those practices to then help us know what to do into the future. We're sharing knowledge from one agricultural producer to another. And then we're actively working to increase the market for sustainable products. So I'm going to go through each of these here in a series of slides. As I said before, this is being led by a number of local folks, and I want to give a huge shout out to the Teton Soil Conservation District. Most of the folks you saw in that previous photo are members of the board of directors of the Soil Conservation District. The Soil Conservation District is led by generational farmers and ranchers. Most of these people have been here in southeastern Idaho for many generations, 4 or 5 generations. And you know, I think one of the neat things is these are some of the most conservative folks I know. And they see conservation and conservative values as going hand in hand. And that to me is really exciting. So it's even part of their name, conservation. But these are not, I think, what I thought of as the people who are really championing climate solutions before I started this work. And so it's really neat for me to see that and to participate with what I consider to be non-traditional partners. I really like this work because it ties in so well with all of these climate initiatives. This is the 4 per 1,000 initiative that is part of the Paris Climate Accord that we will soon be part of again, and ties back to all of that soil work that you all learned about last week. This is why I like this soil health initiative, but it's not the driver for the folks that I'm working with, and that is great. The reason that these agricultural producers are interested in this work is because this soil health initiative gives them the opportunity to try new technology, and I'll talk about that more in detail in a minute. It reduces their costs. They're running businesses. That is what farmers and ranchers do. They run a business. And so it's reducing the cost of running that business. They have to put in less fertilizer when their soil is healthy. When they don't have to spend as much time fertilizing their soil and working their soil, it means that they have to spend less on labor and fuel. So that's another big piece of why they like this soil health initiative. It also increases the ability of the soil to hold moisture And as a result, they have to do less irrigation. Again, less labor, less cost for them for pumping water up out of the ground or into their sprinkler systems. And then as a result, it increases their farm profitability. In some cases, we even see higher yields, but at very least, we see less cost, which then works out to greater profit. And I think the fact that we're coming at this from different places is actually, to me, one of the reasons that this works. Folks who maybe don't particularly care about the Paris Climate Accord, they're actually the ones driving this because of all these pieces and parts. One of the reasons that this has come together is because our ag partners were interested in doing all of the things on this list. We sat down and listened and said, well, gosh, those same practices that you're talking about that do this also lead to healthy water. They also lead to improved soil carbon storage. I think we can get together on this and address all of our concerns if we design this project right. And so here's what it looks like. On the left of my screen, I see what conventionally tilled soil looks like. So conventionally tilled soil, we go through with a tractor, usually around here in the fall, after plants are harvested, clear that soil of all of the crop residue, the barley straw, or the potato vines, or the quinoa stalks that were there. We clear all of that out. We till up that soil and get it ready for planting in the spring with a conventional seed drill. That works well for having your soil ready to plant in the spring, but it's not great for the health of the soil. As you think about all those principles of soil health that you learned about last week, you can imagine that this is not soil that's going to support really great, healthy microbes in it. It's also soil that's going to run off really easily every time it rains or when the snow melts. And so what we did instead is we purchased a seed drill called a no-till drill that doesn't need completely cleared soil. That seed drill, that new piece of technology, allows these producers to plant straight into soil that has not been significantly tilled. On the left-hand side is what conventional tillage looks like. As we said before, typically you go through and plow under all your crop residue in the spring, or in the fall after harvest. You'll often disc it once in the fall. In the spring, then you'll cultivate it, then you'll plant it and cultivate it again. We are working toward moving to the right-hand side of that screen. So we're implementing reduced tillage. So maybe we just cultivate, plant, and then cultivate a little bit for weed control, or maybe we can even do a full no-till on many of our years where all we do is plant into crop residue. There may be still some spraying, but folks are also working on the actual type of spray that they're using and reducing the toxicity of that. So that's really exciting. So conservation tillage and no-till through the use of a no-till drill and just practices that are reducing overall passes, you can see how if you reduce the number of times that your tractor runs over the soil, it's going to improve your soil health and also reduce all the emissions associated with all those passes over the soil. As I said before, another big piece of this soil health initiative is experimenting with cover crops. So you saw that bare soil and the conventional approach before. Cover crops, we come in and we plant, instead of leaving that soil bare, we plant crops that are specifically designed to keep a living root in the soil, that are specifically designed to be used as green manure that can be tilled back or just squashed down into the soil. In some cases, like these two photos on the right, those cover crops can actually be used for forage for animals. So the woman in the middle, Morgan Piquet, is a rancher here in Teton Valley, and they're growing cover crops that can be grazed by cows. And that cow manure then provides additional fertilization to the soil. So we're experimenting with cover crops and then also with managed grazing. So in the left-hand photo here, these cows, there's about 200 cows, and there's electric fences that these folks move every single day. Those cows are confined to a really small area so that there's a lot of manure spread over that surface. They're confined to that area for a day, and then they're going to be moved tomorrow to all this really lush cover crop that they'll graze down. They'll recycle this cover crop with their manure. They'll work it into the soil with their hooves. And this kind of managed grazing can have tremendous impacts on improving the health of the soil, which then improves the ability of that soil to store carbon. On the right-hand side, the Dewey family, who runs Crowfoot J Meats, which is a direct sale beef operation here in Teton Valley, they are actually converting a lot of former crop ground into perennial pasture. So they will never need to till that soil again. They're planting perennial crops that have a constant root in the soil, and then they're doing the same kind of managed grazing where the cows graze intensively for a short period of time on these perennial grasses, and then are moved very quickly, like the next day or 2 days later, onto a new stretch of grass. So that grass can then grow again, store a ton of carbon back in that nice, healthy soil. As I mentioned, we are also really working actively. This is part of what I don't move cows. I don't grow quinoa. I don't plant cover crops. That's not where my skills and experience are best used. But what I can do is I can provide the funding and the connections with graduate students who can go out and gather the data that these agricultural producers are interested in. They want to know how effective am I producing as much forage with this cover crop as I would have by growing alfalfa? Am I storing carbon in the soil that's going to produce a healthy potato crop 4 years from now? Through all of these practices, are my nitrogen inputs actually going to be reduced so that I don't have to put fertilizer that was produced in a chemical plant on my potatoes in 4 years? So those are the data that these folks want, and we're able to provide that through our connections with Boise State and other institutions who can do that really good science. That's then helping to inform the future of this work. Another key piece of this is we're providing producer to producer education. So rather than, some expert who maybe has never actually farmed, we're bringing together the people who are doing this work to say, hey, here's what's working for me today on my farm here in Teton Valley. We've hosted a bunch of farm tours where folks can come out to talk with the producers that are doing this work. We're bringing in experts who are doing soil health initiatives in other places to go walk the ground with farmers and ranchers here. And then we're capturing that in durable resources, recorded videos, this booklet, this Soil Health Initiative booklet. Again, that's on our website if you'd like to check it out further. So this producer to producer education is a really important piece of continuing the knowledge and the learning forward. And then another really neat part of this work, and the last piece that I'll touch on, is increasing the market for sustainable products. One of the entities that we're working with is a group called Salmon Safe, and we've actually created a Trout Safe certification. The ideal world, they've been really successful in creating a great market for salmon safe wine in the Pacific Northwest. And we are working to create salmon or trout safe beer here in Teton Valley. Barley that's used for brewing beer is a major product of our agricultural economy here. And so we're working to produce trout safe beer. The other thing that we're working on right now actively is actually creating a market for the carbon itself that's stored in the soil. The town of Jackson Hole has some really aggressive targets for becoming carbon neutral. They are implementing practices that reduce their carbon emissions. And then they're also beginning to move into a phase where they will be looking to offset those emissions that they cannot reduce. So we are looking to actually create, so because we have the data to verify that we're actively increasing soil carbon storage, we should be able to essentially sell that service. So these farmers and ranchers who are producing a crop of quinoa or barley or beef off of their land are also farming carbon underneath all of that cash crop. And we're working to develop a system whereby they can actually get paid for the carbon farming that they're doing. So really exciting work that's being done by folks, again, who I didn't necessarily think as being leaders in climate solutions, but boy, my mind has really been changed by that. All of this comes back to this overall perspective where agriculture becomes really the solution to climate change, as well as to a number of our other global issues. Just a quick little shout out. I studied at the University of Washington. Dave Montgomery was the author of The Assignment, I believe, that you all read this week. He's one of the leaders in this field, and he was one of my professors. So as an undergraduate, one of my professors was really the person who inspired me to get involved in this kind of work. I don't know if this is exactly what I would have known that I would be doing when I was sitting in a lecture hall at the University of Washington, but that becoming inspired by and excited about the work that Dave was doing is what led me ultimately to doing what I'm doing today. And so I hope that will become the case for some of you. Some of what you're seeing in this course may inspire your future as a leader in developing climate solutions. So I'd like to actually do that same poll again, and just to see if your thoughts have changed. I'm giving you the same questions as before, but how well now does this fit your image or your current image? I think it says previous, but how well does this fit your current mental image of leaders in the field of climate change solutions? I'll give you about 20 more seconds. I see a lot of great participation.
Thank you all. Sorry, I lost you for a minute there. The Boise State internet went down.
Oh my gosh.
So it's back up. Hopefully other folks didn't have that same experience. That was just wonderful, Amy. And it looks like we've got most of the results, and we're going to go ahead and share those. And I really love the question and of, do these folks fit your image of climate solutions? And then all the solutions you just presented. I also wanted to share my own personal anecdote from Dave Montgomery, which was 20 years ago. At least I was at an AGU conference and I was talking about, I ran into him, and he's a real big shot in the world of geomorphology. He's just an amazing guy. And I said, Dave, what are your, climate change? What are we going to do about it? And he said, 20 years ago, he said, well, the solution is in the soil. And I looked at him, I'm like, what are you talking about? And it took me about 15 years to figure out what he was talking about, but I think he certainly is right. And it looks like many of you think that's right as well, where we see agriculture as a solution to climate change. We got some wonderful questions in the chat, and I'm going to go ahead and ask some of those, and then if we have time, we'll try out this mural, but we may not have time, and that's fine. From Chandler, and Chandler, I welcome you to unmute yourself if you're there and ask your own question. You out there, Chandler? I see you. There you are.
Hi. So I guess my question is, so we see most of our carbon emissions and like storage right now, obviously in the atmosphere. And as we're trying to store more into the soil, is there a point where that's like too much carbon and where there are downfalls for having too much carbon in soil?
Yeah, that's a really good question. It's actually one of the questions that our agricultural producers are asking. Can we have too much soil carbon? And we are looking at some of the results we're getting back. We're actually going in and measuring. Okay, when we started, let's get a baseline. What is your soil carbon before you implement these practices? And then what is your soil carbon after several years worth of implementing these best management practices? I think one of the things that we've heard from other places is that there may be a little bit of a threshold somewhere around when you get above about 5% soil carbon, that you may start to see some problems with soil fertility. And so we're seeing increases between 0 and 5% right now. And that's incredible. When you look at the Paris Climate Accord goals, they're talking a fraction of 1% as a goal for addressing global climate change. And so we feel like the numbers that we're seeing are phenomenal, but yeah, there may be a top limit, and that's part of what this research is showing us, and that's okay. I mean, we can deal with that. We can knock down the soil carbon also. There's probably no upper limit for like the grazing lands, or not much upper limit for the grazing lands in the perennial pasture, but the row crops is probably where you start to see that decline in soil fertility. It's a great question. It would be a great master's or doctoral research project if that's something that you have interest in the future.
Absolutely. Yeah, great answer. I just learned something there myself. So thank you, Amy. And one thing that is important to remember, there actually is currently still more carbon stored in the soil than the atmosphere, fortunately, and we're hoping to even increase that more. Two more questions we have one from Maddie. Maddie, would you like to unmute yourself and ask your question?
Yes, hello. So my question is when you're approaching these agriculture producers, are you advertising what you're doing as helping to prevent, like helping to stop climate change or helping to reduce climate change? Or do you approach them calling it something else in case that they're like, do not believe in climate change or are against it?
Excellent question. We call this the Teton Valley Soil Health Initiative. And you're exactly right. Most of the producer to producer education and the sort of advertising to producers is focused really on the agricultural benefits of this rather than the climate benefits. It is neat. It's becoming, it used to be, you know, climate change used to be a bad word or bad words, bad phrase. But we are actually starting to see changes in that. I think there's been some leadership from actually, you know, our governor, who is a rancher, who's willing to accept that climate change is real. And so we're actually seeing some change also, as I think, as we're starting to see a generational transition in who's running farms. Folks who grew up with climate change being something that is real, we are starting to see more acceptance. But yeah, you're exactly right. Our focus with our producers is not on the climate change piece as much as it is on the soil benefits and the agricultural benefits. So yeah, that's really perceptive.
Absolutely, Maddie. And actually, I'd love to have you chat with Danielle. Danielle is really grappling with the same question involving wildfire, and how do you talk about climate change and wildfire in conservative communities in a way that will be effective. So that's just an excellent question. Jorge, are you in a position to unmute yourself to ask your question?
Yeah, I am. Honestly, that kind of helped my question already. On like, because my question was, if this is like the farmers where you're working at, if their mindset is like reflecting like the same around like the rest of the world, but if you're coming at it in the way, if it's not like, you're not pointing it directly towards climate change and like kind of like redirecting it, I think they would be behind it. I think anyone would go behind it if they were farmers.
Yeah, and it's actually really cool that this initiative was initially actually driven by our ag producers. It was their idea because of the farming benefits. And then as they brought it to us, it was like, oh my gosh, there's all this potential for other benefits beyond that which is happening on farm. And then it's provided some opportunity then for conversations. One of my, he's a grandpa aged producers who I work with a lot. He's really a leader in this field. He came in, I remember it last year, he came into my office in the winter and he said, can I talk to you about climate change? What do you think about it? And we had an hour-long conversation about climate change. And I've actually heard him saying some things that are a real difference in his own perspective than what he initially came in with. So it's been really transformative, I think, for all of us.
And that's a
Did she freeze for you guys?
I think she did freeze. So she may be moving back in. I don't know if they're having internet issues at Boise State or not, because it appears that we did lose some participants about the same time that Jen's left. So, oh, she's back.
Can you guys hear me?
Yes.
Oh, we've got a breakout session dialogue. We also need to take our quiz. Can you guys see and hear me? Yes? Okay. So we'll return to that here in a minute. Let's do, I'm going to take a picture of this so that we can do these questions during our discussion period this week, hopefully. Deb, what is the password for the quiz?
Solutions. SOLUTIONS. Solutions.
Solutions is the password. While you are getting that up, I would like to hear Deb's question to Amy, which I think is a great question.
Yes, while the students are accessing the quiz with the password solutions. Amy, have you seen the type of crops change over time in the area due to climate change? For example, you mentioned quinoa, which seems to be an unusual selection for conservative farmers to make. Did they make that based upon an economic choice, or was it based upon the fact that now we can grow crops that are different in that Teton Valley area?
Yeah, great question. You know, I think we probably are seeing some crop changes that I think folks may be starting to grow things that perhaps they couldn't grow before. Those are more of the row crops, the kind of the CSA, organic farm, small farm crops that we're seeing with that kind of change. Quinoa is actually being driven by the economics of it's really, as people are starting to recognize the need to reduce gluten in diets. Quinoa is something that has been a solution to that. And there's a lot of demand for domestically produced quinoa. Interestingly, quinoa is probably more threatened by changes in climate. It needs a very long, cool season in order to flower and produce seed. So it actually could be more threatened by increased summer temperatures, interestingly enough. Most crops benefit from that, but quinoa actually doesn't. So great question. But yes, we are seeing some interesting crop changes.
And as a follow-up to that, are you seeing more of a progression into organic farming in the area, or is it pretty well staying with the same use of pesticides?
Yeah, we are seeing some move to organic. The certification process is somewhat burdensome for the organic. And so we're seeing a lot of people actually kind of bypassing organic and going straight to what they call regenerative. We're actually seeing some people fully bypassing organic and going straight over to biodynamic farming, which is even more significant and really interesting. There's kind of a whole bunch of stuff around, do you actually get certified as organic or not? We are seeing these new certification processes developing that recognize additional practices beyond just those required for organic, or that maybe like the Trout Safe, for example, does still allow some limited chemical use, but focuses on the way in which and the places in which you apply those chemicals to make sure they're not ending up in surface water and groundwater. So yeah, seeing some of both.
That's, I love that question. And Deb actually has long family ties to the Jackson area, which is really cool. I love the dialogue you have for the breakout session, Amy, and I'm definitely going to use that in our discussion group on Thursday, because we're just about out of time this time. Great question from Zoe. Zoe, do you want to unmute yourself and ask your question?
So I was just wondering, so like in this instance, you have the side that might not believe in climate change, you have like another reason for them to get on board with these initiatives, like the economic and those reasons. And so like, do you think there are other fields that this like collaborative approach would work in if there's not these like agricultural positives to it, I guess?
Yeah, thank you. I think you're exactly right. I mean, I think a big part of why this initiative has been so successful is because we really sat down and listened for understanding rather than listening for confirming of our initial bias. So we sat down and listened. What are the challenges that these producers are facing? What are the practices that they want to put in place? And then from there, we could then build on, oh my gosh, okay, well, so how do we fund this? This actually did not start at all as a climate initiative whatsoever. It really started as a farming initiative and a water quality initiative. And then we've been able to say, well, oh my gosh, this ties in so well with all of these climate solutions. And there's a lot of energy and funding around climate solutions. So let's now go use that as an opportunity to bring economic benefit to the people who are implementing these ecosystem services. So I think you're right. I'm not enough of an expert in other realms, but I would encourage all of you who likely are to really think about how can you take some of those lessons and bring them into your future work in other fields.
That's a great, great question, Zoe. And I'm really looking forward to our AGU session on this. What you just said, Amy, about sitting down and listening listening for understanding and not just to confirm our own biases, I think that's a really important. So yeah, great question. Looks like folks are needing to leave. I'm not sure if Cole is still here. Are you still there, Cole? He might have had to go to class. Cole asked, how do you measure the success of this initiative in the world of COVID-19?
Yeah, it's a great question. You know, interestingly, when we're working with agricultural producers, most of these people, I grew up in the West, I grew up in rural lands, and I never get within 6 feet of people like in normal time. And that's the case for a lot of these folks. And so we've actually been able to really move a lot of this work forward almost sort of without COVID. In some ways, it's actually increased our success. We've had more participation in a lot of our educational events because people can do them on their own time from their own home. They don't have to travel somewhere, so they can go do chores and then jump on Zoom and be done and go do chores again. And so, you know, interestingly, we found a lot of opportunity. And our graduate students have been able to come out and just work by themselves doing science out in the field. And so that's been kind of cool. We have had some challenges with labs being closed and that sort of thing. So we've had to work around that a little bit. But for the most part, we've been fortunate that it hasn't disrupted a lot of our work.
I guess that's true. That's the beauty of field work in wide open spaces. You got a bunch of thank yous into the chat.
I see that. Yeah, thank you.
Yes, we do still have Nick on the line, which is great, and other folks. So please stick around if you want to chat with Nick and Amy, but feel free to take off if you need to. Also have our office hours. Nick, there was a question for you from Andrew, and when I lost my Zoom connection, which was mildly terrifying. I'm like, oh God, did it just drop for the whole class? But it didn't. I lost my chat. So I don't know if you saw that question from Andrew.
Yeah, I have it. I'm actually drafting an email for him right now. I think I found it. So.
Oh, good. Yeah, he's a great student. So he'd be a great undergrad researcher. Good. Other questions for Nick or Amy?
Hi, Amy and Nick. I just wanted to say that was a really awesome presentation, and thank you for taking the time to do it. It's really inspiring to see the work that you guys are doing over in the Teton Valley. And I think ultimately, you know, I mean, the bottom-up conservation isn't the only solution, but it has to be part of the solution. You know, we can't just rely on regulation and top-down approaches. And every place is going to have its own solution, but it's really inspiring to see that in this particular place, there is this bottom-up solution that seems to have like win-win-win outcomes. So thanks for sharing.
Thank you. Yeah, I feel like I'm hopeful that as we move forward, we'll have the really great top-down input of funding and support and funding for science that will complement and support these ground up initiatives. That's what I hope.
Yeah. Do you know what kind of, like, are you thinking like from the government? You know, I know a lot of purchase of easements happen through the LCWF. Is that kind of what you're thinking of? Is if you can show success, then that can lead to these regular big influxes of money to support the farmers doing the work?
Yeah, I think both. I think infusion of government supported funding from things like the Land Water Conservation Fund. I think, you know, NSF support to support future research, which you all are very good at getting and would love to partner with you on that more. I think those are the kinds of things. I think we're seeing a lot of support from like the Natural Resources Conservation Service for moving these kind of initiatives forward. So I think if additional funding and sort of a top-down drive for innovation within those agencies and their granting branches. I think that's something I'd like to see. And at the same time, we're also, you know, in all this market development work that we're doing, really looking at private industry as a funding source as well. You know, potential for local governments to participate in climate initiatives that potentially have a carbon offset, market-driven carbon offset component. So, you know, my hope is that we have the ability to really diversify all of those funding sources, and then philanthropy has a major role in that as well, obviously too. So.
Yeah, I know that I have, well, one of our colleagues here, Anand, who's involved in this project, he works most of his time for like Conservation International, and he's in the big international NGO world. But he said, one thing he told me recently is, you know, at the universities, we're seeing furloughs and cuts and whatnot, but actually in the nonprofit world, they're hiring like crazy. Because these big corporations, the Amazons, and they have so much money, they're donating it to the nonprofits. And I wonder, I mean, have you guys pursued trying to get your foot in the door with those types of corporations?
Yeah, I mean, it's interesting to hear you say that. We're part of this Upper Snake collaborative that's working on, their focus is, it's called the Upper Snake Farms and Fish Initiative. And one of the major goals, we hired someone about a year ago, and one of his major goals is to increase our relationships with, and then, you know, ideally funding partnerships with corporate entities. And so we're currently working with some of the large farming, large consumers of farm products to look at whether they would support some of these farming initiatives moving forward.
And yeah, I think that's a really good question. And I think it could be anything from Chobani, you know, if we're looking at other areas in Idaho, potentially to Yvonne Chouinard, to Jeff Bezos, in terms of, but that is something I actually just talked to one of our development directors about in terms of having, and I'll have to pick Jody's brain, but having that kind of planned out. So that's interesting to hear that the observation, Jody, has been that there's hiring in the nonprofit world. So that's good to know. And I do think that, you know, for FTR in the Teton Valley, then the trout friendly beer and, you know, really getting that message through to people who buy the products from Teton Valley, that there's some good solutions out there. So.
Yeah.
Have you tried with General Mills? Have you been in contact with General Mills? Because I know they have a big regenerative farming emphasis.
Yeah, so that is one of the entities that this Farms and Fish Initiative is working to develop relationships with. You know, we find it's often there's a challenge, and there's all these big sustainability initiatives, but actually finding ways for those large corporations to put that money on the ground can just be really challenging. And so we kind of keep bumping up against this. And I'm hopeful that we'll find ways to break through this. It's often a matter of scale. And I think that's something that we realize is that little Friends of the Teton River, we're just not quite big enough. And so that's part of why we formed this larger regional Upper Snake Farms and Fish Initiative with some larger partners that are recognized names, the Nature Conservancy, Trout Unlimited, that I think there may be greater success to be had when we zoom the scale up a little bit. That's our hope.
Yeah. In terms of research, what would you say? You were saying you wish you had more money to do research. What would you say are one or two of the major knowledge gaps that you've identified, but you just don't have the human resources to pursue those?
I mean, one of the things that we'd love to do is to just really be able to, and I think this exists, but to really be able to document in a easy, sort of low cost, well-defined manner, what our, our net carbon change is on a farm to farm basis, so that we could develop the market for that. Again, I think that sort of thing exists. I know they're doing a lot of that in California right now. And so I think that exists. But we don't have access to it here. And so somebody working with us to really figure out, okay, how do we, basically take the carbon we're farming and put it into a saleable chunk, essentially, for someone to purchase, in essence. I think that would be a big one. I think being able to document the changes that we're seeing from each of these practices. I think there's a lot of work to model what the theoretical change in the soil fertility and soil carbon storage, all kinds of different parameters. I think there's a lot of great modeled work, but to actually document the changes we're seeing from the various different practices and the practices in combination with one another, or some of the practices in combination with one another, I think that's something we would love to see. I think there's kind of on both of those levels, there's probably some remote sensing. I think there's some remote sensing work that could be done, so that it doesn't just have to be field measured. Obviously, you'd need some of that for verification, but trying to figure out how to bring those things together to make it maybe a little easier, and even being able to be done from somewhere other than here in Teton Valley. I think you all probably know a lot more about what I'm saying than I do. But so those are of interest. I'm also actually pretty interested in some of the measuring change in the human ecosystem part of all of this, and capturing that, like the change in perspective and how that impacts the ability to do future work, and like learning lessons about why this has been successful. This effort has been successful when that's not always the case. And so some of the human dimensions piece is figuring out how to capture those and then tell those stories in a way that broadens the transferability of this work.
Yeah, those are all great questions. And I think there is a ton of potential. It's just a matter of like finding the right team. Like all of that would fit in a package for a proposal. Just a matter of doing the work to get together to do it. It's all there.
Yeah.
I just madly scribbled down those 4, maybe 5 things. So yeah, thank you, Amy. That's really helpful. And Jody and I have been meeting with other folks at Boise State who are interested in these same questions. Lots of remote sensing, Nick. You've got a full plate, but yes.
Yeah, my knowledge of remote sensing applications, I took like a course when remote sensing was like new, and that's pretty much the last time. And so I would really love to explore a lot further how some of those new technologies could be utilized.
Yeah, but I think with a combination of some field testing and just measuring organic carbon, and which we can do here, and we even have a technician now with remote sensing and Nick and Jody's work. Yeah, I think those are great questions. I'm really glad you brought up this, that you called it the human ecosystem, which I loved. And these changes in perspective and why it's working at FTR. And I've been wondering that too. And what I was talking with Jody about earlier, and which I guess you and I will be probably talking about this evening on our other meeting, is that when you run into people in the grocery store, it's harder to maintain these divisions, and so working on that scale, on the grocery store scale, is maybe where we can enact change. I don't know, but
yeah, I think that the really local nature of this work does play a huge role in it, but that's my bias too. So
yeah, I think that's a really interesting question. Is what is the scale and what are the other parts that need to come together? So anyway,
I'm going to run to another Zoom room, but thank
you
so much. Hopefully, we'll be in contact with you to do more brainstorming at some point.
I would love that. Thank you all so much, and thanks for this really rich conversation as a follow-up as well.
Absolutely. Thanks so much. That was great, Amy. And thank you so much, Nick. It was great to hear about your work. I actually just had a master's student who's just finishing his thesis. It's getting submitted, which does pertain to beaver influences. So I'll send that along to you too. So.
Oh, cool. Thanks. Yeah, thanks so much for having me.
Yeah.
I love it. So,
it was great to meet you. So.
My pleasure.
Thanks, Nick.
Yeah, my pleasure. See ya.
Bye. Let's see, Keaton, are you there? Going to remove Keaton. All right. Well, I thought that was great.
Yeah, I thought she was excellent. Are there other groups similar to that as you go down the Snake River?
Well, there's the Henry's Fork Foundation, which is very close geographically to the Friends of the Teton River. That's more upstream. That's really an organization. They've got a great scientist, amazing scientist, Rob Van Kirk, who I've worked with a lot. He's a mathematician and hydrologist and fishing guide. So he's a huge resource, but the bread and butter of that group are out of town elite fly fishermen coming in and paying.
Oh, so recreation, a big factor. Because we own a farm down by Burley Declo. Just wondering if that same sort of thing is going on in that area.
Well, no, it isn't. I mean, it's unfortunate because the further you go downstream on the Snake River, the more it gets degraded. But I think there is some hope. Again, thinking, I mean, it's a larger community, but I know that the CEO of Chobani Yogurt is very interested in K through 12 education for one, and for making Twin Falls more of a, environmentally friendly community. So that might be, that might be in inroads there. So I don't know.
Interesting.
Anyway. Awesome. I'm so glad. God, that was terrifying. I'm in the and like it just like closed. It's like an unexpected error has occurred. I'm like, oh great. So I'm glad that it didn't drop the Zoom for the whole group. I was worried that might
30 seconds or so after that.
Yeah. So did it drop for you too, Danielle?
I mean, I don't think I was frozen. I
don't think so.
Everything seemed to be flowing for me.
Are you connected on the Wi-Fi or the Okay, I was actually connected previously on the hardwire in my office, and I had to reconnect on the Wi-Fi. So go figure. Anyway, let's see. So we didn't get a chance to try that mural. It's something I was interested. It's like Flipgrid, but you don't have to sign in. Don't have to have an email if you can share it. So that's something I may try to do in discussion in the upcoming week. So I don't know if you can, if you have 2 seconds, just try opening that second link I sent. Okay, somebody added something. Okay, Deb added something.
No, I didn't add that.
You didn't? Oh, I see you in the.
I see the healthy soils.
Okay, you're a visiting ram, so you can, and a visiting snake. Maybe Daniel is a visiting snake.
See me.
So, oh, yeah, I can move the,
Okay, can you, so try right clicking. I don't know how you're supposed to, if you can add a sticky note.
Okay, yeah.
Okay, you are able to add something, okay.
I can't see it though.
I think try making it, you can try making it bigger. Oh, there we go, okay. Yep.
Oh, my name is there, but I didn't add that.
Oh, maybe, so I see your cursor going around, Deb, maybe, and then now just try typing in your
Okay.
sticky note. I don't know. I just want to see if this is something that might work. Oh, you're typing. Yes, you are. Okay. It is working.
It is,
Yeah.
it's a little bit more janky than Jamboard though.
Yeah, the advantage that I see is that you don't have to, thinking about the AGU session too, Danielle, is that you wouldn't have to sign in with your email to get access to it. You can just have visitors comment. So anyway, thank you.
As long as you send the guest link, the other link that you sent, you have to sign, you have to get your own account.
Yeah, thank you. That was helpful. So
The only trouble is they can move maybe you can stick these down so they
Oh.
can't move them.
they go.
There might be a way to stick them down as the leader.
Yeah, I'll have to
That
look.
might be something that if you're going to do it in a huge presentation, a great way to interact.
Yeah, and I tried this other format.
So nice to have those titles up at the top. That helps your participation. That's what I always have them do when they do a Jamboard, is title at the top, and then people can see what silos to put things in, and it provides a pretty good interaction.
Yeah.
And if you can change your sticky color, I don't know.
I think you can. That's a good. Well, somehow you can. Oh yeah, there's
Yes, you can.
Yeah.
It turns in really small.
Yeah, I know it is. They are a little. I guess this format must be huge somehow.
So you can suggest that they change their color, or you can put a specific color in the.
Yeah,
the other thing is they can organize these stickies into patterns. So if all of a sudden a group is working on just obstacles, as they see things come in, they can assign somebody to look for the patterns and start to group together the pattern collector or whatever. That's kind of a cool job on this.
That's what I'm hoping to do in the AGU session, is to do that 20 questions brainstorming on and have look for our key questions from that session.
Yeah. And they don't have to sign in like on Jamboard. You have to enter with your Boise State. It's good for Boise State students because they all have Jamboard. But if you're not a Boise State student, you don't want to go with the Jamboard.
Speaking of questions, I have a 12:30 meeting, so I have to be aware of that. A lot of notes from Nick. I wrote down the question of how does Nick use the near infrared signal? And the answer to that was that he uses near infrared to find areas with water, where the vegetation is showing that there's water. I think would be the best.
Sorry, you said he uses the signal to find differences between the vegetation and the water?
It's actually, so what the near infrared shows is it's areas of riparian vegetation, but I think the easiest, I don't think he said riparian. So I think then for the students, it would be to find signals of water in vegetation, maybe. Another one I wrote down for Amy.
Is water in vegetation a good way to stay? Because all vegetation has water in it. Is it more
Wetland vegetation?
wetland? And he did say the word wetlands.
To find, yeah, you could use wetland, maybe would be better.
To locate wetlands or areas to help rehabilitate those wetland areas.
It's, well, it technically is also riparian vegetation.
Yeah.
But, and he's using it to find areas with water that will green up sooner. Maybe it's too complicated. We can scrap the.
Maybe just the first part of that question is find areas with water.
Yeah.
Just the first part, rather than complicate it with the vegetation stuff. He did make a big point of finding that water had a definite signal that was different, and that when he compared all of the different tests that he did, that water stood out in a better detail. So I just stopped with water.
Okay, that's good. Let's see. One of Amy's early slides on climate impacts just show that the climate impacts in the Teton Valley area are include earlier, faster runoff and lower summer flows.
Yes. Faster, low summer flows.
Also increased water temperature was one of them.
Yeah.
Yes.
Do you want me to include that one on there? Okay. And then I could, yeah, I can make it like a multiple answer one.
Let's see. Kind of under the title of the collaborative conservation.
Yes.
And she was great. She gave students enough time to look at the slides, so hopefully they got this. But I had that would result in lower carbon emissions, increased carbon storage in soils, decreased conversion of agricultural land to development. Those were the big three that I had.
Yes, she said it was, and then before she got into those three, she said it was guided by local knowledge, community participation, and science.
Mm-hmm.
Collaborative conservation. And then the result was to reduce carbon emissions, increase storage and carbon in soil, and reduce conversion of the ag land to developed land.
Yeah, I wrote that was her the regenerative agricultural initiative, the goals of the regenerative agricultural initiative.
That's what she called it, regenerative agricultural initiative.
Yeah.
Okay.
Maybe a separate question on collaborative conservation, working together. Maybe what is collaborative conservation? Working together to bring local knowledge, community participation, and science to sustain both people and places.
Yeah, that's a great.
Yes. That's a good question. And then the solutions that collaborative conservation provided were reducing carbon emissions, increasing storage. And then the conversion of agricultural land to developed land.
All right, so that's 4.
After that, she talked about the methods that either reduced carbon or carbon farming, not absorbing carbon dioxide, cover crops, maybe something about cover crops. She stressed that a couple of times.
Yeah.
The benefits to agriculture, is that what you're?
Or yeah, maybe the benefits to the farmers, low cost, reducing fertilizer costs. Well, the benefits with stressing that farmers are doing this because it's a business solution.
Yeah, and that the other, that conservation and conservative values go hand in hand. So those two are also ones I wrote down. But yeah, that carbon storage makes sense as a business solution.
There was low cost, low risk way to try new technology. That no-till drill was interesting, that can push through so they don't completely eradicate that cover off of those fields, and would reduce erosion immensely. I'm thinking about when you drive through those what used to be dry land, still many up in northern Idaho, that would completely take off all cover, and you'd see that massive soil loss down the gullies. And yeah.
Yeah, I was wishing we had more time, because that's a great, there's a great experiment or demonstration I do in the lab where we've got those in the soils lab, and you can see it's truly is like a sponge, if it's got more organic content. So
yeah. So does that give you 5?
Yeah, I'm not clear on what the 5th question should be exactly. I can word.
You could have something
true false, maybe.
True false, yeah. Conservation and conservative values go hand in hand.
Yeah.
Sounds good.
Did you see that comic strip Danielle remarked on? I sent through email. It's kind of a cool way to introduce soil science to students that like those comic strips. I had never seen that before.
My daughter is totally into comic strips, so I was going to print it off for her too.
And I know there's students who they love comic strips. I never, once I passed Archie and Veronica stage, it was just.
I love it. I'm actually going to see if I'm going to use this in my the AGU session. Yeah, it's great, actually.
Yes.
I'm looking at it right now. Yeah.
And the fact that the woman, she gave the TED Talk. That's how I found that, is I just kept following her links, and it's a great example of diversity too, a female scientist of color. So
I love this. I was going to harass Asmaret to see if she could give a talk sometime at Boise State. Yeah.
Yes, that'd be very cool. And also on that En-ROADS, did you see the En-ROADS doesn't open up that students are not able to play with the levers? They just no. It's all that is a PDF in that list of questions she provided.
Oh, did you let her know about that yet?
No, I remember after I looked at it as a PDF, they don't want them playing with them, the levers. They are holding that total control to themselves. All they want us to do, and that sparked my memory, is they present the video, present the PDF, talk about those fringe items of policy. And then the students were supposed to have some sort of feel for how those policies would affect other entities, whether it was other policies or people's, and then choose their solution policy, which lever they might move, and then where to pick off of that list. If that's what is that what you kind of remember her saying, Danielle? Or am I just all wet?
That's good to know that it, so they're just supposed to look at it and try to anticipate what might happen.
Mhm. Yeah, so there's going to be no adjusting or no, they're not even going to know how moving one moves the others. That's what she was trying to get at when she said, based upon their solutions, if we don't have any that get to temperature, then they have a couple of scenarios that they're going to present that get us to temperature.
Gotcha. Yeah. All right.
You guys
So
your student, oh, sorry, Deb.
Go ahead, Danielle.
Oh, I was just wondering if you guys have had any emails from your students panicked when they upload their poster presentation. The Blackboard preview kind of scrunches everything. It makes the formatting look all off. So I've had a number of people email me about it. They then try to resubmit, do it in different ways. It's fine though. So I emailed those people back, and then I ended up sending out a group email to alleviate everyone's concerns that I actually download it in PowerPoint and it looks fine that way. But when they upload it, that Blackboard preview makes it look like it didn't upload correctly, and your text boxes are all on each other. So
for their posters.
Yeah.
Oh, okay. And you sent that out to the whole group?
I sent it to my 2 classes. So I don't know if you guys have gotten any emails from your students, because I've gotten. I finally did that after the 3rd one.
If you don't mind sending that to the whole class, that would be great, because I'm sure ours will have issues as well. So
I got a couple of that on the draft poster that they submitted a couple of times because their formatting seemed off, and I didn't know what they were talking about because I saw it perfect. So
yeah, I told them I download it into PowerPoint, to grade. So it's fine when you do that, but that Blackboard preview makes it look like it didn't upload correctly.
Oh, good. If you could put that on the announcement page for all 10 students that read the announcements. Or just send it. I would put it on the announcement page, but also send it as a email. You can check that email box to email all students, because
yeah,
my confidence level in the announcement page is dwindled too.
Well, the ones that'll get worried when they upload it and it looks all scrunched are the ones that'll get the email. So
yeah, over Thanksgiving, when we don't plan to answer emails back to them when they start to panic.
I'll be in Bozeman next week. Oh, am I frozen? It says my internet is unstable.
You've got traumatic, you're triggered now with the
I am. Yes, I totally am, because I'm worried about this session at AGU and having wrong.
Can you have a laptop right by you so you can transfer to the laptop quickly and email and just log in on both?
I only have one laptop. This is my laptop.
Oh, and you're going to be out of town.
So yeah, anyway. Well, we'll
take your kids.
What's that?
Take one of your kids' laptops. I always am logged into 2 different things when I present, just in case I had to transfer over, and I give my second co-host ability.
Yeah. Oh, that's
so before you disappeared, my co-host ability would be able to transfer to that other machine, especially when you've got a lot on board with being the AGU.
I'll make Danielle be my co-host.
Exactly. Make sure you do that before you leave, and she knows that, because when you left, it didn't provide any sort of blurb in the force when you left.
Well, no, that's great. And they're supposed to be an AGU technician, so hopefully they'll be host and have stable internet. But I'm going to run and go to the bathroom before my next couple of meetings. So I will. So no official meeting next week, but definitely let's be in touch if there's any issues. I will, I still on my list is emailing John Beater to find out about any latitude with students and grades. Hopefully the ones who are not doing well see that extra credit opportunity.
And are you coming to class on Thursday or?
I will let you know. I'll either come or I will provide a video or an edited video for you, and I'll try to come and show it. So
Because it's harder to do the video for a long time because it does stagger really bad in my class.
okay, good to know.
So
Then yeah, I mean I can come and we can I'm trying to kill two birds with one stone, both by giving the students my presentation and recording it for AGU. So since it will be recorded on Zoom anyway, then we could maybe use that. So.
okay, but all we're doing on Thursday is the En-ROADS, other than yours.
There's the En-ROADS, there's mine, but then there's also the breakout room discussion questions that we didn't get time to do with Amy that I took a picture of.
I've got those too, but
I have my phone with me to take a picture of those.
they're actually in her email that she sent us.
Oh, okay.
But without her being there, it's going to be pretty difficult to facilitate that discussion when it gets down to more collaborative efforts in the Teton Valley. I don't know any much more than what she just relayed to us. So, and taking the case study forward in our work as leaders in climate, the breakout would be great if she was there to facilitate, but I'm not sure.
Yeah, well, we certainly don't need to do that. I think so. I just thought I'll probably try to do it in my class.
I might pull a couple of them and we can.
Or I can try this this mural thing again if I come to your class, Deb, and ask those questions and ask them to post post-its for it. So.
Okay, well, let me know how much time I need to fill with coming up with ideas for keeping them busy.
I'd say let's don't worry about anything else on your end other than the En-ROADS prep.
Okay. That sounds great.
All right, great.
Thanks.
Bye.
Bye.